right, I'm going to call to order the work session, March 18th, 2025. And there is a meeting logistics and facility and safety awareness posted on the screen, but I'm not going to go ahead and read that. So let's hand it right over to you guys.
All right. Good evening, commissioners. I'm Brian Booth. Thank you for joining us this evening. We have a very fun and exciting agenda item to chat about. I have a couple of the real experts up here with me. Juan Serpa Munoz and Ben Ulrich, who you've met before, the leads on this project. So let's go ahead and jump into it. We've got an hour. So first of all, some disclaimers. There is a heavy number of asterisks on this report. This is a study of potential. Practicality is limited by, in one breath here, staffing, programs, ramp rates, customer willingness and ability to participate and or financially contribute, contractor capacity and interest, and equipment availability. We have assumptions that are built into this that we believe make it realistic. They are all assumptions. Some of them are going to be wrong. This is our best guess at what's out there and what's really achievable. This study will inform a planning process that will include research of all of the above, guiding principles, scenario evaluations, budget setting, and eventually a conservation implementation plan. So all those to say, got to click for me, Ben?
Oh, yeah.
Let's not put the cart in front of the horse too much here. It's really exciting. There's a lot of potential out in our service territory to be able to do more. Just don't want to jump to too many conclusions. This is all informational. All right, so with that, I can hand it over to Ben to get started.
Great, thanks, Brian. So back in 2023, we did our IRP, and one of the action items from that IRP was to do a study of the potential for conservation and demand response in our community. So when we look out in the future and plan our power supply, we wanted to know how much could happen on the demand side of the equation. And so we hired a consultant in 2024, Lighthouse Energy Consulting, and we've been working with Ted Light and Sophia Spencer, who are the two consultants, and they've been fantastic to work with. They are experts in the area of demand side studies, and they started with regional assumptions and looked at the 2021 power plan that was published by the council. They started with those assumptions, which took regional data and then downscaled it down to EWEB. So we used EWEB-centric data about our building stock, attributes of our community, to make sure that those regional assumptions were scaled appropriately to our community. And so we think that's led to much more accurate results, and we've got some really great data today that will help kind of paint a picture of what the future could look like. So in your background materials, you received the draft copies of the demand conservation potential assessment report and the demand response potential assessment report. And Juan and I today are going to provide some context to those numbers and provide some two complementary perspectives, mine from the IRP mindset or system planning mindset, and Juan from the implementation program side of it. So before I go to my first slide, which is your first chart, I'm going to put us in the IRP mindset, which is thinking about cost effectiveness. At what point does it make more financial sense for EWEB to invest in conservation when comparing it to buying new wind, solar, or batteries, things like that? So instead of investing in new resources to meet our load growth, what can conservation do for us? So this first slide, the headline number here is 85 average megawatts of potential. So that's the dark green shaded area shown here. And so the first comparison I thought of is, okay, let's put a dotted line to show our forecasted load growth in the future. So that's the black dotted line. And so that 85 average megawatts of potential is the top of the green shaded area. And the consultant, in order to feed the integrated resource plan, they broke it out into levelized cost bins. So when you put something in terms of levelized costs, it's in $1 per megawatt hour, and it allows you to compare the cost of that measure, that conservation measure, relative to the cost of a new wind farm or solar. And so I've oversimplified it here and broken it into two bins of two different colors. The first is the dark green shaded area, which is all the measures that cost less than $45 per megawatt hour. And then the upper lighter shaded green area is everything that costs $46 and above. And that range goes very high. It goes all the way up to like over $600 a megawatt hour. So some of these measures are very expensive. And when we think about cost effectiveness, I think of the numbers in the back of my mind is the Bonneville contract. Bonneville is one of our least cost resource options in our portfolio. That's around $39 a megawatt hour. New resources like wind, solar, battery can range from $55 to $65 a megawatt hour blended in our IRP modeling results. So when we think about the likelihood of that under $45 bin being cost effective, it seems very likely to be cost effective. In fact, when you do a weighted average of all those measures that are inside that bin, the weighted average is actually $17 per megawatt hour. So many measures cost much less than 45. And then the last piece of context I wanted to add is our current conservation targets is in the dotted blue line to just give you a sense of what we're doing today. If we did that same thing for the next 20 some years, that green dark shaded under 45 category shows a lot of potential. It's roughly double what our current measures are today. So very exciting possibilities. And so emphasizing that idea that the load growth is what creates that need for new resources, I wanted to say, okay, what does it look like to take money from your purchase power expense budget and instead invest into conservation programs? And so we worked with a consultant to come up with a rough estimate of what those future spending, might look like. So in 2030, the green shaded area is around $2 million a year. And in 2045, that number grows to $8 million a year. So conservation is not free. These would require investments in programs and measures. But then I thought, okay, well, if we can put that in context of if that saves you on even your cheapest resource option is Bonneville at $39 a megawatt hour, how does that compare? And so I put that gray shaded area of $39 a megawatt hour in the background. So the concept here is you're avoiding paying someone else, paying a generator, paying Bonneville, and instead choosing to invest in conservation. So it's that kind of avoided cost concept. The other thing I want to make in that green spending, that includes the cost of incentives like rebates, and it also includes staffing and overhead costs. So it's kind of your anticipated spending to achieve that under 45 category. The other caveat I would add is these measures are maybe different than what we do today. EWEB's current conservation measures are based on our values and not simply focused on just cost effectiveness. So we're going to provide some more context into the measures and the composition in that bin when Juan presents. And then lastly, peak savings. What are the peak savings potential? So if you can offset roughly half your annual energy load growth with conservation, what about our peak load growth? Can conservation help with our peaks? And the answer is yes, it can also offset roughly half of your peak load growth. Again, this is only that under $45 per megawatt hour bin that we're talking about. And then we zoom in and say, okay, what are some of the measures driving those peak savings in these study findings? And so residential smart thermostats, residential duct sealing, and commercial lighting are three programs that are really huge components of these peak savings. And those are indicators of programs that we might be interested in if we want to go after this cost-effective bin of measures. And so to provide some context to that, I'm going to pass it off to Juan.
Everyone. Yeah, thanks, Ben. This under $45 per megawatt hour bin presents an opportunity for substantial, achievable energy and capacity savings. However, this bin implies an intentional approach to cost-effective energy conservation, which in many ways is different than our current approach, which is more of a responsive one to customer interests. Over the next 3 slides, my intent and goal is to provide a general overview of considerations of the implementation of this bin to help bring you context of this potential. To start, let's take a look at the measure composition of this bin. To clarify, the percentages that you see on these 2 tables for the commercial and the residential sector do not add up to 100 because I'm only highlighting those that have the highest potential. On the residential side, which provides 30% of the savings in this bin, 43% of them come from heating, ventilation, and air conditioning, or HVAC, which highlights smart thermostats and duct sealing as having the highest potential within that category. On the commercial side, which brings 40% of the savings, 47% of those come from lighting, and 26% of those come from HVAC, which highlights strategic energy management and fans as having the highest potential within those. The next slide, please. To provide a better understanding of the implementation considerations for some of these measures, I will now focus on the duct sealing measures and example. Duct sealing is the repairing and sealing of ductwork applicable to homes with forced air systems. These homes use ductwork as the delivery mechanism for heating and cooling. The duct sealing measure is an example of how, in order to pursue the savings in this specific bin, programmatic changes and additional considerations will be critical in the near and long-term future, including those to business processes, contractor engagement and partnerships, and staffing, among others. Looking at the graph, the bars in gray show existing single family as having the highest potential. Multifamily, where we tend to find the large portion of rentals and limited income households, do not appear in this graph due to ducted systems not usually found in these types of buildings. EWEB completed one duct sealing project in 2024. However, we would be looking at increasing this level of participation in a considerable manner in the next few years, including, as the graph shows, having over 1,600 projects in 2036. This high level of adoption would mean that about a third of single-family homes would have to have gone through our duct sealing program in the next 22 years. Bringing this level of participation will not be solved simply with higher incentives. We would need to explore a completely new approach to increase participation, which could include directly working with contractors to increase the awareness of our programs, but also hiring installers to directly do installations and direct duct sealing to homes in our service territory. Next slide, please. The board and our community continues to show interest in the limited income and rental sectors. However, our current popular programs, including those with high adoption in our income-based efforts, such as ductless heat pumps, insulation, windows, live in the over $120 per megawatt hour bin, and some of these specific measures have a much higher levelized cost. On the graph, the yellowish areas are savings from households that would qualify for income-based programs, while the bluish areas are from households that would not. In general, about 34% of all households in our service territory could qualify for income-based programs. However, 70% of the savings in this bin would come from households not eligible for EWEB income-based programs. This is due in part to most residential savings in this bin, 86% of those coming from the single-family sector. Multifamily, where we find most rentals and income-eligible households, would bring about 4% of the savings in this specific bin. I want to remind them I'm talking about this specific bin, not savings in general. Multifamily tends to have lower energy consumption, but also reduce opportunities for energy efficiency and measures, especially those that are cost-effective. The conservation potential assessment highlights the under $45 per megawatt hour bin of conservation and conservation in general as an exciting opportunity for EWEB to substantially achieve both energy and capacity savings. Although there is some overlap between this bin of cost-effective conservation and our current programs, these are two separate strategic ways of implementation, especially when considering the customer participation that would be needed. Further evaluation, programmatic changes will be needed to balance EWEB's values of reliability and affordability that this energy conservation bin provides with those of community and accessibility that in many ways drives our current customer programs. The demand side potential assessment and its conservation potential assessment are one component of the process, but not the entire process. As Brian mentioned, it does not tell us the full picture of achieving savings, including capacity, supply, demand, affordability, practicality, and willingness to pay. To understand a conservation planning process will be needed. This process would include further review of the results by staff, development of scenarios and costs, and a conservation implementation plan to outline actions, measures, and timelines for implementation. Now I'll pass it to Ben.
Thanks, Juan. So now we're going to shift gears and switch over to the demand response potential assessment. And I kind of changed the header on this slide to say demand response and time of use potential, because there's some intermixing here of what comes first. So when the consultant looked at the potential for demand response in the community, their key finding was there's about 50 megawatts of peak saving potential through demand response programs. And the approach they took is they divided them into direct load control programs versus pricing programs. So direct load control is where you would sign up for EWEB. EWEB would pay you a small fee and you'd sign up for your smart thermostat, and then 4 or 5 times a season, EWEB would tell your thermostat to preheat or pre-cool and avoid a peak. So that's a direct load control program. Whereas a pricing program like time of use is where EWEB just provides a price signal and the customer voluntarily changes how their thermostat runs in response to those price signals. And so we tried to look at what are the biggest drivers of that 50 megawatts of potential savings. What were the biggest demand response opportunities? So I'm going to start with the green shaded area at the bottom. That's your residential EV charging. So shifting the EV chargers away from your peaks. And then on top of that is the blue shaded area, which is your water heaters, and that's heat pump water heaters or electric resistance water heaters. And then the orange area on top of that is your smart thermostat for heating or cooling. These are just the winter DR programs. And then the last one at the very top there is the brown shaded area. That is behind the meter storage. So picture that like a Tesla Powerwall that a customer buys. And this is out in 2040, so we're very far in the future, where a customer has their own battery and then they sign up for EWEB to occasionally use that for demand response. And then the very top there is that kind of thinner fuchsia pink color, and that's time of use. And so our first question is, why is time of use so small? And it's because it's assuming that the remaining households who don't participate in direct load control programs, those remaining households would participate in a voluntary time of use program. So we have flexibility on how we go about implementing demand response. And so if EWEB were to start with time of use rates first, and we implemented that first, it's very likely that that would cannibalize the participation in the direct load control program. So that fuchsia color could actually be the whole area in theory, where people voluntarily change their EV charging, they voluntarily change their water heaters and space heaters in response to a time of use pricing. So I just want to say it's demand response / time of use. And so, yeah, that's the idea, is that they could capture some of those savings through pricing alone. And in the context of what is cost effective, those demand response programs are estimated to cost less than a new utility scale battery. So instead of purchasing a 4-hour lithium ion battery, we would look to invest in demand response instead. And when you combine the green under 45 category of conservation, the peak savings potential there, along with the blue demand response potential savings, and you kind of compare that to our peak load forecast for the future, you can see that you can offset most, not all, but most of our peak load growth with these demand side options. And that's really exciting potential. And I think we as staff are really excited to see that amount of potential peak savings coming from demand side. And it will require investments to get there, but I think that's really exciting. And I think some of the other context that we want to add today is when we look at implementation or this shift in focus towards cost effectiveness, there's going to be challenges to that, and it's going to change the way maybe EWEB approaches conservation when we have this laser focus on what is cost effective and going after that particular bin. And so I think that's some of the context that Juan was hoping to provide today as well. So hopefully that's provided some food for thought and will spark some discussion. With that, we can pass it back to you.
Thank you. This is well presented. I really appreciate it. I'm not lost, and we've been in 20 minutes, so thank you very much. Real quick question: our duct sealing program. Can you tell me what that is? You said that we have a program. That's first I've heard of it, and
Yeah, so we have a duct sealing program. It's available, but we don't get a lot of participation. And last year we had, I believe we had like, in 2024, we only had one, but previous to that, we had in the 30s participation. That was because whenever somebody install a ducted heat pump system, they were required to do duct sealing. And so BPA let go of that requirement, and now we're seeing in 2024 just one project. So the program has been available for years. It's just the adoption is really low. It's not something that customers necessarily, they can't see their ductwork, they can see their windows, they can see the different things. So it's not something that they pursue intentionally, and contractors sometimes may not be incentivized to promote these programs because they're not making necessarily a lot of money on that. You can install a heat pump and not necessarily look at your ductwork and then just move forward. But then the savings are really come from that sealing, because it's kind of like if you're watering your lawn, you have holes on your hose, you know, that water is going everywhere, your attic, your crawl space. So it's an important piece of any forced air system. Unfortunately, we just don't see a lot of
I
participation.
think, given the fact that it's a pretty high return, that, you know, would be something that we would really be jumping on. So another quick question about more of the macro, and that's, you know, demand response and things such as that, behavior modification, because you're talking about the commercial end of this and about you being able to control when to ramp up and ramp down. Well, our largest employers are government. You think of the U of O, City of Eugene, Lane County and all that. They're the big users when the courthouse goes. Has anybody even given thought to saying, you know, instead of working 8 to 5 and everybody ramping up, because government, you don't have a choice. I need a planning department or a courtroom. I have to go whenever they're open. About just changing their hours of operation or encouraging them to do so through incentivizing a price break to say, change your hours of operation. And we've got our major employers, and all the big buildings are ramping up at 7 instead of 8 or 6 instead of 7. And by that, just by doing that, just making that request and giving them a financial incentive to do that.
I would say that's not in this study that I'm aware of, like that particular program, but I think those are the kinds of conversations you can have as you start exploring what potential's out there. I will say what stood out to me was of the 50 megawatts of potential, like those the industrial and kind of shifting of larger customers was forecasted to be fairly small in this study. And I think they're just using very broad assumptions about typical programs. I think EWEB has a lot of room to create custom programs that could get those savings, but it requires a dialogue with the customer.
Okay, thank you.
Comment.
Commissioner Brown, what I would just say that you just pointed out a really good example of time of use, which is there would be an economic incentive to move to a different time, and in some ways an economic penalty to remain business as usual. And so with large customers, we would probably typically negotiate that in whatever sort of contract we have with them. And we do know that some of them are already interested in time of use.
Okay, because you know, utilities are the second largest operating expense of buildings. And so I would think that we could give them an incentive to do that. It would slow down our peak. So thank you.
I just inject one thing. I just wanted to make one reference clear. Ben referenced the council as a regional basis for when he started. That's not the city council. That's the Pacific Northwest Energy and Conservation Council, who works in a multi-state region to set the energy efficiency targets for the region, including Bonneville. So just didn't want to get anyone confused when he made reference to the council setting these expectations. This is a different council in this case.
Couple questions. One, I was also intrigued by the duct sealing. What is the cost to do a duct sealing on a house?
It varies, depends on the complexity and what may be needed, but what we're seeing is around $2,500.
$2,500
Plus.
Okay. So a couple of things that jumped out at me when I was going through the items was, one was the program administrative costs. They said that the industry standard was 20%, but using EWEB's numbers, it jumped to 27%. Is that just because of the way our utility is set up with generation and water and those types of things? Or why is there such a discrepancy between our administrative costs for these types of programs and, let's say, the industry standard?
I'll have to look more into that, but when we did the calculations, they came up to 27%, but I'll have to research a little bit more why it is that it is different than the 20%.
And that, yeah, and then that just jumped out at me. And then one of the other things that, oh, did you want to?
Yeah, I can add a little bit of context to that. Some of it is that we do energy efficiency conservation, not just for return on investment purposes. As you know, we have a pretty large content that goes to limited income support, rental support. These are more expensive measures, and we don't always stay just within the Bonneville deemed programs. We engineer some of our own. So that probably drives up our overall cost a little bit.
Okay, it just jumped out, 7% of that for admin. Anytime I see admin costs, it sends a flare up. Because I mean, that's a quarter of the money, right? 27% is more than 25, is more than a quarter of what we're spending just to implement a program. So at some point, the cost benefit is diminutive. The other thing I noticed in the demand response was how stark the contrast was between the achievable winter demand response potential between residential and commercial. The residential is huge and commercial is just very small. That was on page, it's way down. It's not on one of your slides, it's on page 8 of their report. But so when I saw that, it kind of made me think about the questions that I put forward. It's like there's businesses and things that can't really do demand response. And if we see that the big bang is in residential, is there a way that we can do our demand response that is looking at the business side of it and saying, these businesses can't really do demand response, and the bang for the buck on demand response that they're going to be achieving is so small that we don't want to penalize them, and just really lead into the residential when it goes to winter peak and demand response. When I saw that graph, it just really jumped out at me as I don't know if there's a way that we can design that, but when I see the numbers that are so stark, it just makes me think, let's not try to penalize our businesses and commercial people for such a small return. Those were some of the things that I took away.
Yeah, Commissioner Borowski, I think one of the things to consider in the case of when you're looking at business opportunities, a lot of these become application specific. I think when we look at standard programs where you're taking something and you're replicating it across a large customer base like residential, you're gonna see more potential. I do think there's opportunity in the commercial industrial side, but it's going to be very specific to the application. Whether they're running one shift or two shifts, whether they're dealing with heating processes that have thermal momentum or not. I mean, these are things that we could discover that there's one or two accounts that would equate to 20,000 households, for example. I mean, this is just something that we have to look into further on an application by application basis. Your point is correct. We want to be careful recognizing that some businesses have more opportunities than others to adapt. Some are base maneuvers that would apply to everybody, and then some are going to be application specific. And we don't want to lose sight of that also.
Along those same lines, it might be that you only have to work with a few businesses to get that same level, whereas you might have to work with hundreds of or thousands to get the same level of, achievement and savings for a residential side. I mean, there's just so many more individual homes than there are businesses, individual businesses. I'm curious on the commercial lighting side, since that was noted as such a big portion of it. My understanding was that some of our commercial lighting incentives are actually going away.
Yeah.
Is there some look at changing that then?
Yeah, that's a good point. So BPA is they're either going to sunset, or because now you can no longer purchase compact fluorescent lighting for in Oregon since 2025, then BPA is looking at the baseline and possibly sunsetting some of those measures. And so that would imply that EWEB, if that takes place, there would be a new baseline and the level of refunding, the reimbursement that we would get from BPA would change. If that were to be the case, and EWEB still wants to pursue this under this bin, the large amount of savings on the commercial side, then we would have to consider what level of that incremental cost we want to pay now. Whereas before we got X reimbursement, maybe we're getting a quarter or a fifth or maybe none. And so the CWIP want to implement that. But based on the levelized cost, it implies they would still be valuable for EWEB and cost effective to pursue that full incremental cost. But again, after staff evaluates and explore this further, then we can find out what that right number would be for EWEB. And that is part of the consideration or the use of something else that we're looking at including, which is the cost effectiveness calculator that would allow us to evaluate per measure what it is the right amount of incentive that EWEB, how much the customer pays, how much the utility pays, and what makes something move forward.
Because I mean, if they're going to purchase it anyway at some point, but how long does it take for, an older style CFL before it actually dies and needs replacing just naturally?
Yeah, the incentive incentivizes you to like, oh,
Right.
maybe I don't have to replace it now, it's still going, but I'm going to go ahead and do it.
You can do it now versus just waiting until the end of life of the current.
So the potential would still be there, like potential in lighting will still be there. So ABC widgets might say, instead of, because there's an incentive and changing that today, I'm going to wait until it ends. So it would still take place. We can just have a role in incentivizing that out in a faster time frame that we have those rebates.
How long do they typically expect the older style CFLs to last?
I'm not sure, it depends, but I'll have to look.
Because I mean, that tail of how long it takes before they just naturally go out, that kind of plays it into it a little bit. Okay, well, thank you on that. I'm curious, can you just give me a sense, this $45 per megawatt hour, what does that equate to in terms of the size of a project for an average business or an average household? Because that's just a weird, I understand in the utility term, like that makes more sense from where you're coming from, but when we're trying to relate to it and look at an individual level, it's hard for me to wrap my brain around, like, how much money are we talking on an individual project basis?
So that considers the levelized cost. If you're thinking more about a specific measure, like connected advanced thermostats, for example, then that unit may be $240 and our incentive is going to be like $140. Is that how you're meaning, or?
Well, I mean, if you're doing it on the amount of savings of a particular project, essentially, I mean, you're trying to delineate these projects are too expensive because they don't get that cost savings. They're too expensive versus these projects are, in that savings realm that we would want to go after. I understand you put those projects up there, but it still doesn't, for me, it would just be helpful to know what those, like what the cost of those projects are. Does that equate to a $300 project? Is it a $1,500 project? Is it a $5,000 project? I mean, like, sense of scale for a home versus a business. And I know businesses are wildly different, so that's probably a harder one to tackle. But at least on the residential side, if I could get a sense of like what that translates to.
It would vary depending on the life of the measure. So each measure would have a life. For example, connected advanced thermostats have a 5-year life, and whereas like insulation would have like a 45-year life, but insulation doesn't make it on this. So then you would consider the incremental cost, how much it costs from a non-energy efficient method.
I understand how to do it. I just want a number. If, like, maybe you can't do it now, but if you could get a number, like do that math at some point and bring it back, that would be helpful. I understand how you have to do it. I can't do that on the fly here. So at some point it would be just helpful to know, based on these projects, if you go back to the residential side of the projects that kind of meet that side.
Duct ceiling.
Yeah, no, not this one. Where it had residential versus there. Here we go. So yeah, that one. Like, okay, so for the smart thermostat for the residential side or the air source heat pump, how much do those projects usually cost if this is the kind of projects that we're doing? Or on the, on the commercial side, this is how much these typically cost, and this is how much we think we would need to pay to incentivize.
Okay, yeah, so, okay, so yeah, so for example, on the duct sealing, that would be like a $2,500 cost. On the connected thermostat, it would be like a $240 cost if you go for the high end.
So instead of them just like paying for that energy over that amount of time with the current old technology, we would instead say it's actually better, $2,500 worth to just put in a new one that's more energy efficient now because it's going to save X amount of dollars over the life of that product.
Yes,
Correct?
that is what the potential is saying. That on
Okay,
duct
but-
sealing, paying 25, the incremental cost of that measure would benefit EWEB, and it would fall under the bin of $45 and under. Now, duct sealing may have a specific levelized cost, but it falls within that bin. But yeah, we can come up with some of those. When you're trying to ask what is the right incentive to provide, that would fall more on the cost effectiveness calculator to understand what that sweet number may be in consideration of the value to EWEB from different lenses.
Okay, so the project costs $2,500, but the incentive may not need to be $2,500. It may only need to be
500, 600, 700, whatever it needs. And also how much customers are aware of these programs as well. Because maybe you need to have a higher incentive to build it and then that goes down. Or maybe just higher spending on outreach just to get that participation to increase. And then once contractors have that awareness or is well sold, then that can decrease. So there's a lot that goes into it, but I think I'm understanding and we can look at coming up with some of those scenarios for you.
Okay, great, thank you. And then I had one other question. So the direct load control, are there other utilities that do this right now? And how do they protect themselves from a liability perspective? I can just see somebody saying, well, they came into my system and they ramped up my heat. Now my bill is XYZ. And
Can I offer two answers? The first one is a snide one, that anything is possible with a contract. The second one is that yes, there are other utilities that do this. I know that PGE does it. We had done a pilot on this at Snohomish with several hundred participants. It was partnered through the manufacturer. So like I have an Ecobee thermostat. We worked directly with Ecobee to do a demand response pilot with these customers.
Mhm.
So we could call on it for 40 hours total out of the year. We'd press a button that would send a message to Ecobee and they'd turn everybody's thermostat down a degree or two in the winter or up a degree or two in the summer.
And would the customer have any input into like, I got a notification, actually, sorry, that's not going to work for me today, but another time? Or
I don't recall if they got like a text message notification. They could absolutely walk to the thermostat and just zero out the change that we had made though.
I see. Okay.
Yeah,
Okay.
there's a-
So they still have choice
Yes.
otherwise. Okay.
Yeah, there's absolutely the utilities that have done it have created boundaries around what those look like, either a number of times called upon, the limits of which you can make adjustments. And also the customer in all of their cases have said they can override this for their own reasons, whatever those are. People really have a hesitancy around letting someone else take control of their important I mean, we fight over it in our own households, let alone having someone else involved with it. And so I think that, and we're also seeing other utilities do wrestle with this. What's an aggregated benefit? A whole bunch of people doing a little thing versus the industrials each doing a big thing. They have seen potential in both areas. And so I think we want to keep both of those options open. To your earlier question, Commissioner Carlson, I think, Ben, to translate a little bit based on what you've done in the past, I think what she's also looking for is when we did the electrification study and showed what's the benefit for the participant, for EWEB and the community, having a few examples that would highlight that would also show where the incentives potentially could be as part of that. So there's this overarching potential and benefit, but also recognizing that in some cases we might not have have to, it's just, there's a savings there for the customer. There's all kinds of willingness to do it. It's a great investment. In other cases, we have to may seed that. So I think that's partly what you're looking for.
Yeah, absolutely. Just that translation so that we can, I mean, when somebody is making a decision, as a community member out in the public, and I don't know, I look at that and it's not digestible, which is fine. So, but that would absolutely help. And then as policymakers, then we can, understand where that incentive dollar, might need to be. And found a lot in the other work that I do with Brain that urgency helps a lot. So if something is constantly there, people are like, I don't want to do anything with it. But if it is diminishing or will go away, that really sparks interest. So I just throw that out there as a design feature that maybe we rotate different ones around and have pools. And so it spurs some, interest around the different programs. Okay, that's it for me. Thank you.
Thank you, Chair. This is a lot, but it's a really great information. Thank you for the presentation. I echo Commissioner Brown. It's very digestible. There's definitely some percentages that I definitely need to reread to have a full understanding. And I wanted to comment as well as Commissioner Borowski. This is the perfect screen. When we talk about commercial versus residential, I think on the practical side of scheduling and doing that with a residential home and with the thousands of residential homes, you'll be doing a lot of scheduling and working around. But if the goal is to get to 100% achievable for like fans, for example, that'd be great to, that's, I assume, possible even during business being open. So probably a lot easier to accomplish that. I just wanted to make those comments. For the residential duct ceiling, one project complete in 2024.
Yes.
Can you go in 30-ish back in 2023? You said you looked back a year before as well in 2023, and there was roughly 30%. It wasn't on a slide. You were responding to a question.
Yeah, I believe there was 30-something projects that we had in something similar to the year past. And that was, again, because there was a requirement to implement duct sealing whenever a heat pump was installed. And BPA let go of that requirement in late 2023. And so a lot of utilities let go of that as well. So they saw a decrease in that specific measure.
I appreciate that. That was primarily my question, was why. So thank you. You answered my question.
Yeah, I think it's going to be an interesting opportunity for us from a marketing perspective. And in particular, I think it was mentioned working with contractors. And I actually had, I was going to say my duct sealed, but that sounds wrong. The ducts on my house, underneath my house, were sealed. And it was about a $3,000 bill. But what was interesting was the contractors who were working on it wanted me to put in a new heat pump. They came on, they wanted a new heat pump. Oh, that's going to solve your problem. I had a new heat pump. It wasn't damaged. And so I think working with contractors is going to be an important part of the channel to this market. Because there'll be things that make sense from an energy efficiency conservation standpoint that may or may not be in their initial best interest. And so this is going to pose some opportunities for us. I think it is encouraging, and where the $45 comes in is we're looking at, we can invest in a resource, we can invest in conservation. And if conservation is not only more affordable economically, we haven't included something like the cost of carbon in this, which is also something that would be a benefit, less energy, less transmission, and there's also other benefits to the avoided use of energy. But I think it's a good sign that at least half of our peak and half of our forecasted growth can be mitigated through these efforts and affordably mitigated. And that's pretty exciting. I think as we dive into it further, this is not to say, commissioners, that this is the only reason we would do energy efficiency or conservation. You have all expressed other reasons to do it around social benefits. Those may not be as affordable. Just recognizing that there would be a difference of doing that and the intent of that versus this. But it's pretty exciting to note that there's possibilities to mitigate higher forecasts in the future through demand side programs. So I think that's encouraging to us.
Well, I think this is really exciting, and I'm curious what comes next, and realistically, when could we think about starting some of these programs? I know that everything's getting more expensive. We've raised rates, and resources are becoming scarcer, so it would be great to get a start on this.
I've got my own thoughts, and I think these two will probably chime in. I'm taking it back to this slide about like long-term vision. This is such a long-term study. And we just got these reports, like it has draft marked on it because we were so anxious to show these results and like share the excitement with you. I think we have a lot more conversations to have about what implementation might look like. And when I think of like strategy, I think you have to look at realities on the ground and study results and bring those two together. So I think my sense is we're starting that journey now. We've got some good data that tells us this is worth spending time on a long-term basis. And then I think we have some real challenges on implementing these particular measures. If we're interested in these, I think we need to look at those study assumptions. And then Juan mentioned a cost effectiveness calculator where we can play with those assumptions, say, well, what if it costs us a little bit more, a little bit less? Do we still want to do that measure? So yeah, I view us as kind of just starting this conversation. I'm anxious to get started as well, but I think it's a complex topic, and I think it really does require top-down and bottom-up thinking to come together, and I think that takes time and communication and collaboration. So that's my own sense of it. Is I think there's more dialogue to be had before we set strategy.
We like to add to that. So yeah, we have the draft report, but we're just getting the data, and really the beauty is in the data. Like the report tells you one thing, but all these graphs and things that you're seeing, that comes from the data and the analysis of that. We're gonna get a conservation potential assessment, all the data, the demand response, but then you got electrification and solar too. So how do all these things play together? It's a really fascinating future to take a surgical approach to our programs in the future, but that doesn't come from the report. That comes from the data that we're going to get at the end of this evaluation. And then the cost effectiveness calculator will let you understand, well, what is the right price that should be for each measure? When you're looking at all of these substantial amount of measures that you're considering, then that is that amount of work times all that. And then what would be the right programmatic approach? What would be the right marketing approach? We have a lot of adoption or not? What is the community want? What are the values of EWEB? So there's a lot still to, I think, work and consider to make something take place. But I think it's a very, very exciting future that we have ahead of us. And working with Lighthouse has been really fantastic in the information that they can provide. So I would say stay tuned. And I think there's a lot of excitement from staff on all of this, but there's also a lot of consideration to context, because it sounds great, but you really need to understand what is needed to actually implement this. And then we can come back to the board and say, this is what it looks like if you wanted to pursue this.
I'm not sure. I think there's also some discussion of potential 2-on-1s with commissioners to talk more in depth. So you may have further conversations with staff coming up as well.
I'm curious, would we ever consider like a more immediate kind of pilot project or something? I know John Brown has talked about that when you were on the board, you did something with kind of time of use or demand response. And I know that there are probably a not insignificant amount of people out there that would be willing to voluntarily participate in some kind of time of use or demand response. And I'm just wondering if it would be possible to try something like that, and just that would give us some like real data, and also would potentially help in advising other customers who do have high bills. If we have some like real here examples of like, look, we had this project and this is what happened.
We've had pilot programs in the past on demand response, including heat pump water heaters, and the price signal just has not been there for the customer at that time, nor for EWEB. And so there's a lot of challenges also in the communication protocol that you're using. if you're leveraging Wi-Fi, for example, and that Wi-Fi goes away or the password changes, then we have had those pilot programs. I think we would look to technologies that can do that in a more automated way so that there's less that a customer has to think about. But again, we can definitely review the pilot projects that we had in the past and bring those results, which have voiced concerns with the price signal and also the communication standards that seem to present challenges to this. Time of use seems to be a nice way to implement something like that because it's up to you, but you can use things like the Ecobee that can actually think for you and you don't have to worry about it. And so when you combine like the conservation advanced thermostats with time of use or things like that, I think it presents a potential that is more realistic and feasible than perhaps direct time of use demand response. But again, we've had pilots and we can review those and present the results to you. That is beneficial.
And Sonia.
Yeah, thanks. I think the timing of this has really two important purposes. One is that we are in the process of looking at various contract options with BPA, and it's important to understand what we see as the local potential that drives the assumptions around what our future contract options might be and what the impacts are. And I think that Ben was trying to highlight that piece of it. Thus, the timing is really important for that right now. The other one is to look at the long term. I do think we're going to have to approach marketing a bit differently. There's sometimes when you be first and run fast, and you might not be perfect out of the gate, but you continue to improve to understand things such as price sensitivity versus acceptance rate, for example. We have found, looking at not only our own time of use studies, but also other utilities' time of use studies, people are very enamored with this very early on in the pilot. Some people even bet with their neighbors who can save them more money. But over time, you have to make sure that the signals that you're sending warrant the ongoing behavior you're looking for, and that can vary. So this is not kind of a one and done kind of marketing effort. This is going to require EWEB to be product managers and manage this stuff going forward. And we are excited about this too, Commissioner. And I think getting some of these things out, we can do that in relatively low risk ways, but we also don't want to send false signals so that people get turned off. We don't want to have so many false starts that people don't trust us. So we want to do a good job with that. And that's the balance that we're going to have to look at.
I'd like to encourage us. So if we go back, I think the smart meter, where it has the residential versus the commercial again. So it says the smart thermostat. So something that the county did to encourage businesses to clean out their stormwater drains was that they contracted with a particular company. I think they went out for an RFP, whoever bid to get the bid, but then they would get a standard rate that was significantly lower because they get this whole bulk of business. And so I don't know if that's something that we could do, but it seemed like it could be a really innovative way to get some of the smart meter thermostats, like just maybe get 3 or 4 of them that come in bid, and we say, great, you can select these, and then within a certain amount of time, the residential customers can get a very low rate. Maybe it's subsidized, or maybe it's just due to the efficiency of scale. And so they have a few businesses that they work with, and then we bring that in that way. Anyway, just an idea, food for thought.
Thanks. One of the things that I'm encouraged about in the report was the utility distribution savings that we can achieve from this. So we're going to have to buy less transformers. We're going to have to buy less substations going forward. And so for me, that's where, the demand response and those things are good. And kind of Frank talked about, well, will it go there? But doing these ones that are long-term savings, sealing the ducts, getting heat pumps installed, that's going to be good for 8, 10, 12, 20 years of savings, pays off, one, for the customer, but it really pays off for us as a utility as well, because we're not having to buy all of these. We're going to have to buy a lot less infrastructure to serve these people. You know, that was one of the things, 34 substations, 29 commercial substations that we may not have to buy over the next 28 years. These are, I mean, you see it on the consent calendar. These are big ticket items. And if we can get these people to do these long-term savings that may cost us $2,500, you know, it may cost us $2,000 to do that, but how much did current substation cost us, right? So, you know, if we have to pay $1,000 to 1,000 people, that's $100,000, but that's a tenth of what current costs us, right? So that's the way that I'm looking at it as well, is what can we do that are long-term, that's going to really lower our cost of infrastructure going forward.
Just want to yes and that. Like, I like, you clearly have read the report because you're talking about the transmission and distribution deferral assumption that was used. So when I presented these levelized costs, this is what drives these costs down is the avoided cost of transmission and distribution upgrades. So those are baked into these levelized cost numbers.
I saw there's two things on the income impact. So one, there's a section that says income ineligible. So I'm assuming that means that they make too much money to get the incentives from our programs. That doesn't mean that there couldn't be some, again, unique ways to create those incentives to tackle that group. And then the other side of it is that we do, if we were able to target strategically the homes where we continue to pay for, you know, our community cares program, and we look at that cost savings, I assume that this doesn't take into account any of those dollars, correct? The amount that we're paying into infrastructure, or does it? Well, we subsidize people's bills directly, and not to fix the problem, but just to pay for their energy because they're low income, but also many of them, I'm guessing, have homes that are very inefficient because they're renting, and there's that divide. So does this take into account any of the dollars that we pay annually into that, or is that just kind of small potatoes in the bucket?
It doesn't look at energy assistance payments. It
Okay.
looks just at the potential of energy conservation.
So if we were able to target that to that, then we also potentially get the savings on the other side if they're now in a place where they don't have to get energy assistance dollars.
Yeah, and I think you would have to consider what your intention would be. If you're looking at cost-effective energy savings, and may not, as it shows, it will not be in the limited income sector. So income eligible means that they qualify for our limited income programs, not for our, so it is ducted heat pumps, ductless heat pumps. Those tend to be in the not cost-effective bin, so they don't appear on this. So those are our regular programs that we have, which are not necessarily cost effective, but it's something that is in alignment with EWEB's values to support our community. So that's why in my presentation I was saying that there's two different strategies here.
Mhm.
One is the cost effective strategy, and then the strategy that continues to support our current programs that may not fall. There's a small gap.
There's not really a lot of overlap in the
There's some, but
ones
not
that are-
much. Like insulation,
Okay.
it doesn't fit into this bin. Whether windows does not necessarily fit into this bin. A small amount of ducted heat pumps in manufactured homes fit, but most of them do not. Ductless heat pump does not fit.
That's because the cost to install the insulation is.
Yet the
is-
incremental cost is so much more than it is if you put something else. And so again, there would be two separate strategies that they're trying to pursue. So if you're trying to pursue cost-effective energy conservation, then that approach may not be in alignment with that.
So I want to encourage us again to look at those innovative ways. Like if we had potentially a contractor that was like, I will just do 100 homes and I'll give you a break on it. It might mean that we push some of those down into the cost effective category and tackle both. I don't know, but it's worth looking into. Because I'd like to, if we can, because I'm a maximizer, I would love to tackle both of those situations. We get a good situation for the person who's in a rental and we tackle our energy situation. But I'm just guessing a lot of it is because it's like a one-off here and there and people have to individually do it. And that's just, it's so time consuming and frustrating for people to navigate that process because it's not something they do all the time. And so just getting over that hurdle of, yeah, I know it's something I should do or could do, but it's so daunting to do. So the way that we can make it easier, the more effective any of those programs are going to be.
Can I make a quick comment? Do you mind, Frank? One of the things, in addition to focusing on cost effectiveness, because that's really important, and we do have so many values across the board with affordability and supporting our community, et cetera. The real focus of this study is on where lies the greatest potential. We've chosen to focus today on particular buckets that are most cost effective, but we're also really thoughtful about, like, when we start to think of conservation more as a resource, where is the greatest potential within the community? So it's about cost, and it's also about what we can achieve.
Last. No. All right, well, thank you very much. And before I adjourn, at 6:15, the board will meet with the general manager in executive session under ORS 192.6602I1 to review and evaluate the employment-related performance of the CEO general manager. And this meeting is now adjourned.